In this video, we're going to be looking at ionic formulae. We'll start by looking at atoms forming ions and also talk about group ions. We'll also then look at ionic formulae, and finally we'll finish by looking at the dissociation of ions. So if we were to draw an atom of sodium, okay, you should be able to draw the electron configuration for sodium, or the electron diagram for sodium. And if you're not sure about this, it's worth having a look back in the atomic structure and periodic table notes. You should also be able to write down the number of positive protons, negative electrons, and neutral neutrons inside this atom. And you should recognize that because we've got the same number of positive protons and negative electrons, this is an uncharged sodium atom. All atoms on the periodic table want to achieve a full outer energy level, and sodium can achieve a full outer energy level by losing one electron. And if we draw the diagram to show when it's lost its one electron, it would look like it's the configuration for electron configuration for neon. So we show that this isn't actually neon by putting this in brackets. The reason why it's not neon is because we haven't changed the number of positive protons. That's what determines which element it is. But what we have done is we've reduced the number of electrons by 1. So we've upset the balance between positive protons and negative electrons, and we show that we've now got one extra proton compared to electron by putting the plus sign outside the diagram. This has now formed the lithium ion, which has a positive charge, telling us it's got one extra proton compared to electron. And this would be the nuclide notation for the sodium ion. The number of electrons an atom loses or gains in order to get a full outer energy level tells us the valency of that particular element. So sodium here lost one electron, so it has a valency of 1. Look at oxygen as an example. Again, you should be able to draw the electron diagram for this one and write how many protons, electrons, and neutrons you've got in an atom of oxygen. And again, in order to get a full outer energy level and become stable, oxygen in this case wants to gain 2 electrons. So again, you should be able to draw the structure when it's gained its 2 electrons. And again, although this looks like the electron configuration for neon, we show that it's not actually neon by putting this in brackets. And again, the reason why it's not neon is because we haven't changed the number of positive protons. And anything that's got 8 protons in its nucleus is going to be oxygen. What we have done though is by adding 2 electrons, we've upset the balance of positive protons and negative electrons, and now we've got 2 extra electrons compared to protons, and we show that by putting the 2 negative charge outside this diagram. And this has also now formed the oxide ion. And again, the 2 negative charge here tells us we've gained 2 electrons in order to form this ion. Non-metal ions, we end their name in IDE when we form the ion as well. Metals keep their same name, but non-metals change to IDE. In page 8 in your data book, you'll see there's a table called the group ions. And as a group ion name suggests, this is just a series of different atoms going around as a group. So here, an ammonium group ion has 1 nitrogen and 4 hydrogen atoms going around as a group, and the whole thing has a charge of 1+. The charge here can help us to work out the valency of this particular group ion. So anything that has a 1 positive charge will have a valency of 1. All of these group ions are here, you can see have got a charge of 1 negative. So again, these are all going to have a valency of 1. These group ions here have got a charge of 2 minus, and the 2 here tells us these will all have a valency of 2. And finally, phosphate here has a charge of 3 minus, so that's going to have a valency of 3. So you should be able to work out the valency of ions by looking at the charge on the ion. So if it has a 1 plus charge, it's a valency of 1, a 2 plus charge, a valency of 2, a 2 minus charge, a valency of 2, etc. And you should also be able to use the group ions on page 8 in your data book to work out the valency of the group ion. And the valency is just the number that's on the charge.